Hello guys, welcome back. Now, in this video, we're gonna start with a new concept, that is the concept of free fall. So this is the concept of free fall. Now, what exactly is free fall? Let's take an example. Let's say we have a building and you are at the top of the building. Okay, you are at the top of the building and you are holding a ball in your hand. So let's say this is the ball. So this is the ball in your hand. And what you do is you just release the ball. Okay, so as soon as you release the ball starts moving in the downward direction, and its velocity keeps on increasing, and ultimately it reaches the surface of the earth. Now, if we analyze the whole situation, what we learn is initially at this height, the velocity of the object was zero in the downward direction because you were holding the ball. As soon as you release the ball, the velocity of the ball starts to increase, right? So because the ball starts to move, the velocity of the ball increases, and as it moves downwards, the velocity of the ball keeps on increasing, and ultimately when it reaches the surface of the earth, the velocity of the ball is maximum. So initially it was zero, the velocity started to increase, and ultimately it was maximum. So at t is equal to 0, v is equal to 0. At t is equal to t final, velocity is maximum. Now, the velocity is changing. The velocity is changing from 0 to maximum. So there is a change in velocity, right? So change in velocity means that there is acceleration, doesn't it? So there is an increase in the velocity, that means that there is a change in velocity, means that there is acceleration. Now, the most important thing over here is the acceleration on the objects near the surface of the earth, if this is the surface of the earth, and these are the different objects. So these are the different objects. Let's say these objects have different masses. These objects have different masses. Now, provided that the objects are near the surface of the earth, all the objects are gonna experience the same acceleration, irrespective of their masses. So the masses are different over here, but the acceleration due to gravity is gonna be the same. Here in this case, the ball starts to move and eventually reaches the surface of the earth because of an acceleration due to gravity, isn't it? It's gravity that pulls the ball towards the surface of the earth. So this acceleration is due to gravity. So this acceleration due to gravity is known as g, and its value is 9.8 meters per second squared. And this is a constant acceleration. This means that over this journey, the velocity changed, but the acceleration was always constant. So the acceleration made the velocity change, but the change in velocity itself was constant. That is, the acceleration itself was constant. The change in velocity in per unit time was always constant. Right? So the acceleration is constant. This is the constant acceleration g, and this constant acceleration g is the same on all the objects near the surface of the Earth, irrespective of the masses. So let's say we have one object of 10 kg and another object of 20 kg, and they at a certain height above the surface of the Earth. That this height is gonna be relatively smaller than the radius of the gravity. I mean, radius of the Earth. If this is, let's say, the radius of the Earth, the height is much lesser than much lesser than the radius of the Earth. Then the acceleration due to gravity is 9.8 meters per second squared, irrespective of the masses. So on both the masses, the acceleration is gonna be 9.8. Whether it's 20 kg or 100 kg, still at that particular height h, the acceleration due to gravity is gonna be 9.8. There was a famous experiment done by Galileo. Galileo was an Italian physicist. So Galileo, what he did was, on the Leaning Tower of Pisa. This is the Leaning Tower of Pisa. So what he did was, he took two different masses, and released two masses from the same height. So what he observed is, over a period of time, both the objects reach the surface of the Earth at the exact same time. And that's when he concluded that the acceleration that both the objects had was the same irrespective of the masses. So the acceleration, in a sense, is not dependent. Acceleration due to gravity is not dependent on masses of the objects. So all the objects near the surface of the Earth are gonna have the same exact acceleration due to gravity, that is 9.8 meters per second squared. And this is known as a free fall, because when the object was released from this height, it was released and not thrown. Initially the ball had velocity 0. If the ball was instead thrown, initially the velocity would not have been 0. So the ball was allowed to fall freely. That is, there was no external force put on the ball by you. It was just a force of gravity, nothing else. No other force, if we consider the friction of the air. So this is the concept of free fall. Okay, so that's it for this video. I'll see you guys on the next video. Take care.